as before, I think we're ready to take questions. And they're getting over there. So first questions here from Berlin. Yes. Maybe you would like to come front, then that people can see you in Montreal. Thank you. Because they can move the camera.
Yeah, one of you spoke about the debris we have in space, 100,000 of it. I've heard about some projects to harvest those debris. Can you develop on that? Have you heard something about how to get it with big magnets and harvesting spaceship to get rid of the debris or collect them even? My name is Thomas Anderson. Yeah.
Yeah, very good question. I didn't touch on that, but there are several companies and government programs who are looking into cleaning up space with different types of systems. And I, frankly, my company is not involved in that. We are basically delivering product to these people to understand where they are so they can go grab them. But as far as I know, I know of two leading companies doing this. One is Japanese and one is European, and they're basically at the beginning of this new market because it's a complicated process. So they are doing demonstration to capture a known debris, and they will be doing that, I think, in 2024. And we're talking about relatively large size stuff. You do need different technology to go after the smaller stuff versus the big one. And if you're asking me to how much artificial intelligence is used for this, the answer is yes, but I don't really know.
Okay, thank you. Vera, do you see a question over in Montreal? Look here. Yes. If you don't have, oh no. You have one or not? I don't hear you. Yeah. Your panel's helping you? Okay, we see guidance. A microphone is wandering around. Thank you.
Yeah, hello. Yeah, Brian Cook from Callion. My question is for DLR. Could you expand a little bit on the lessons learned? You say your ground software has been running for 6 years approximately. Could you expand on your lessons learned? How often you retrain your models, for example, or what you've learned about predictive degradation of your systems, the health of your satellites, etc. Thanks.
Yeah, so thank you for the question. So the 6 years is when we started this project, just to clarify. We've been letting it run now for 1 year operationally, which is a bit less, but I think the lessons learned are identical. So one, touching on the subjects also of the speakers before me, or after me in this case, is that the data quality is bad, but we have to deal with bad data quality. So I think the efforts to increase the quality of the data has to be there. But of course, we're always learning on the job. So there's lots of things we didn't anticipate in the data. So might be funny, but perfect data, like perfect sine waves of GPS sensors, actually we had false positive detections because we didn't anticipate them when we were building our model. And at the same time, there's lots of operations that are performed very rarely in the satellite, on the satellite, which we now try to include with user feedback. So we do few-shot learning approaches. User label them in the front end if there's a false detection. And if it comes to that detection again, let's say, for example, Grace follow-on, they change the position of the satellites every half year. So they change which satellites follows the other. And we detect that as an anomaly. They label it once, the next time we don't detect it. So we include user feedback to improve. And on retraining the models, we do it weekly currently. So every week on the weekends, we retrain the models. But it's a classical approach. It's not a deep learning approach. It's a classical approach on how to detect anomalies. So I hope that answers the question from Montreal.
All
We're
right.
having another question here in Montreal.
Okay. We don't see the people asking the question, so if you could identify yourself, that would be helpful. Thank you. We don't have sound in Berlin.
Okay, can you hear me now? Okay, I can hear
Yeah.
me now much better.
We
Great,
hear
can
you.
me
Thank
as
you.
well? Okay, thank you. My name is Mark Jormich. I'm the head of the DLR Washington office, and we heard several of the speakers mentioning the need for more training data for the AI. And the last speaker, Oliver Lang, mentioned the use of simulated data. So my question would be to basically everyone on the two panels. Is that something you can apply also for your specific application or your specific use of AI?
I'll volunteer and answer first. Yeah, so the data is certainly a challenge. We did train our model for terrain classification of the moon before flying. So there was various strategies we used. Number one, we looked for as many images as we could find from previous lunar missions, including public images shared by the Chang'e 3 and 4 mission by China. There were Apollo mission images that weren't as useful to us, but we certainly investigated them. So you look at past missions which might have similarities in the data. Then you look at generating images either in an analog environment where you attempt to simulate the visual fidelity. So we did that in our lab. So we have a Moonyard area where we did our best to simulate the visual fidelity through lighting conditions and things of that. And then you, of course, augment that data set as well in various ways. You can do that. And then synthetic data was something actually we didn't use for that mission. We explored it using 3D rendering and different kind of high fidelity kind of gaming engines for modeling in that way. But generally speaking, when you're approaching a problem where you just don't have a lot of data before you get there, even simulating that data, it will only get you so far, and you can't reliably trust it to be sufficient for a mission critical use case. So it is our view that to some extent, you have to go through a commissioning phase in flight for an on-open application. How long will that take? What do you need to do to monitor the performance is a bit uncertain, but certainly our philosophy on it is, fly and figure it out as you go. And that means you're not mission critical until later, but it's sort of part of it in our view.
Would you like to comment on that as well here, panel in Berlin? Yes, you have a microphone next to you.
Yeah, just to complement, the way we use it is really we are starting with real data as much as possible, and we create a model which is working for specific under specific conditions. This is well described, and what we try to do with by using synthetic data is to push the boundaries, so to create a bigger value space for the model to go further and further towards a more general model. Then what we do not do is to train mainly on synthetic data. That is not the case. We start from real data, validate, and then we push the boundaries.
That already answered another question we had here from Berlin, but please go ahead. Vera, do you see other questions in Montreal?
We have one more question here.
Hello, David Neveu from GCC Aerospace. I have a question for Michael, actually. You mentioned that AI will be deployed as a payload. Actually, you suggest deploy AI as a payload in space, but how you see the conditions to to pass from, let's say, payload implementation to be basically the solution that will be, say, the basic solution used in space. So how do you see this transition happening between the two, basically the two implementation?
So, sorry, just to understand correctly, you're saying transitioning from it being sort of a payload to kind of mission critical software?
Exactly, like from a payload to, so, because I guess when it's operated as a payload, you have a mission critical system that ensure, let's say, the safe operation of the spacecraft.
It's an excellent question. I think it boils down to a question of level of autonomy that you are relying on in your mission. Is this something that just augments what you're doing, or are you relying on the outputs of that algorithm for a critical use case? And then, of course, there's different classes of missions. So a commercial mission, wow, certainly there are standards, and you want to verify against that. At the end of the day, it's a risk profile, an economic risk, right? If it's a private company doing this. But for a human-rated mission, that's a completely different story to completely different rigorous V&V requirements. I think we're at the early stages. You're seeing a lot more of onboard demonstrations in the last, I would say, I believe the first deep learning network deployed in space was in 2019 or 2020. So we're really at the early stages of just getting the algorithms to run on board. Now I think we're starting to enter into this phase of understanding how to monitor performance of these algorithms and then upgrade in flight. And when that becomes mission critical, you're going to need fallback systems. You're going to need other things like that around it. Fundamentally, I do think it's a different philosophy in how you adopt these techniques. And of course, there has to be a benefit, right? Because that's a lot of effort to figure out. So it really needs to yield a benefit to go through that. Hopefully that answers your question.
Excellent, thank you.
Thank you. And as Benoit Suren is getting ready to wrap everything up, I also want to encourage you, it's not just questions to the audience, it's also we talked a lot about cooperation. This is also a networking event. We have Matthias and Vera over there. If you in Berlin think, please bring me a card or connect me to somebody, indicate it now. The same for you in Montreal. If you want to say, hey, I want to be in touch with Leonard, please raise your voice now and we connect you. Okay, but I think you had another question over there.
Yes, indeed, Alex. Short moment, please.
Hello, everyone. I'm a Polytechnic student, so I would like to thank the German-Canadian concourse and Mrs. Cowett for getting us on board. So I've just finished an internship at the European Astronaut Center in Köln, and we've had the pleasure to work on NLP-based software. And so Mr. Faragali and maybe Mr. Schlag in Berlin. My question is more about, so can you maybe elaborate on the balance between the standardized validation processes and the need for innovation software? I know it's a bit of a hard question, but maybe if you can elaborate on that.
I'm always happy if panels get challenged, especially by knowledgeable students. So go ahead. Leonard is already taking the mic.
Yeah, I mean, I'm taking the mic to not answer your question, basically. So sorry, because as we're doing mainly research, or the NLP section from, I'm also working on NLP, so local LLMs and so on is also a hot topic for us, of course. But luckily, we don't have to worry about the standardization so far, because we're currently researching on it. The data stays with us. We can't put it on the cloud anyway, because it's sensitive data. So if you come from the NLP domain, one of the areas where we're looking into it is, you all know ChatGPT has been mentioned, I think, often today. But we want to do the same thing for anomaly reports, that if engineers say, hey, there's this and this problem, they can ask a bot in a way and maybe get an additional insight quicker than they would if they would look up a manual. So retraining large language models with user manuals, with anomaly reports, and everything that we have text-based, which there's plenty of, also due to regulations. But we don't have to worry about the aspects so far, which came up in your question.
Thank you.
I'd like to venture a comment here. I'm not sure if I'm going to answer your question directly, but here's what I'm thinking with AI and ML. There's tons of data to analyze, and we need scientists to do jobs. And right now, at least for North Star, but as we evolve, we're relying on our scientists too much to do the brute force work and not enough on AI. And I think this is where AI is going to help to relieve the scientists from doing its intelligent work, but it's good enough for the machine. We want our humans to do the thinking, the innovation. That's where I want my staff to be thinking about these tough problems rather than just crunching data.
Go ahead.
Sorry, my mic went. It's not an excuse. I'll try to answer your question. It's a great question. I think fundamentally, machine learning, data-driven approaches, the way in which you develop them and even use them in practice is highly iterative, right? So you're constantly retraining. So we talk about training, deploying that model, but in real life, these models are constantly updated, the ones we currently use on Earth. Fundamentally, space is risk averse, and inherently it is incongruent with that development approach. So how do you reconcile the two is fundamentally what needs to happen. And while I shared some thoughts on how you may be able to approach that idea of iterative and updates, the standards don't exist. And I think we have to like bring that iterative nature into it and sort of not wait till it's perfect to fly and actually learn by doing. Inherently, though, that means you can't rely on it in a mission critical sense. And so what you'll often see now, right now we're in a phase where there's a lot of demonstrations, right? There's a lot of demonstrate. Look what we did. We did ship detection, orbit, or cloud detection. You'll see a lot of that happening, or it's starting to happen. But you know, if you look at a human-rated system that's flying to lunar orbit in the next couple of years, like Gateway or any related systems, no one's going to be relying on machine learning for anything safety critical yet until that comes up to speed. So I think it'll take time, and things will have to evolve. I think we could take a lot of lessons from other sectors, though. So if we look at the aeronautics sector, which I found extremely interesting this morning, they're talking about these things because they could actually go out there and fly. I think one of the presentations from Berlin earlier today on the drones that were doing firefighting, that all iterative approach is built into how they develop that. They just don't have to put it on a rocket and fly it to space and hope for the best. They can just go outside and do it. So how do you bring that into space as space becomes more democratized, more access, thousands upon thousands of satellites in orbit? I think that starts to kind of unlock the potential. But I think on board is going to take a few more years for it to be like at the level that you could rely on it.
Is there anything else like the panel that you would like to add to what has been said?
Yeah, maybe first off, I apologize for my frail voice today. Maybe I need a beer or something stronger too.
It will be provided. It will be provided.
I just had a thought. I mean, maybe one approach to bridge this gap between AI and bringing it into mission critical applications could be sliding autonomy, so that you keep the human in the loop, and step by step you kind of test the system, and it learns and improves its capabilities. And when you're confident that it works properly, then you release it like a child into the wild.
It's a very poetic image. Thank you very much. And looking around Berlin, I don't see any further questions. What about Montreal? Vera?
No, Alex, we don't seem to have further questions here.
Okay, then I want to see big applause in Montreal and Berlin for our panelists here at session 1 and session 2 here at the German-Canadian Concourse.